Hello everyone. We have the following problem. Evaluate integral from 0 to 1 x squared ln x dx. So we have an improper integral foremost here because x equals 0 makes the function x squared ln of x discontinuous. So when we have a place of discontinuity, we will go ahead and set up improper integral. And just to recall, like the notation, the way that works is that you're going to go ahead and write our integral out, and where you have the discontinuity, which is at 0, you're going to replace that with a letter of your choosing, call it b or whatnot, and then you're going to write limit as b approaches, again, it's always the letter that you pick to replace that discontinuity with. It's going to approach that value 0 in this case, and there's from the right or left. Now, it's from the right because of the following, because if you look at the original interval that was given to us from 0 to 1, if you're approaching 0, it has to be from the right, because 0 to 1 basically includes all the numbers less than or equal to 1 and greater than 0 here. So greater than 0, it's like from the right of 0. That's why we have that here. Okay, so once you do that, you're going to go ahead and integrate the function x squared ln of x dx. And the technique that we're going to use here is we're going to use integration by parts. So I'm not going to go over that. I'm just going to show you what the u, the du, the dv, and the v are. So u is ln, du is 1 over x, dv is x squared, and v is 1/3 x cubed. And I'm going to apply the integration by parts formula, and you have 1/3 x cubed ln of x, ln x from 1 to b. Yeah, and with integration by parts, we put the bar after the uv part here. So 1 to b, and then minus 1/9 x cubed from 1 to b. So if I were you, I would go ahead and maybe just stop the video for a second and work on that. And when you plug in the limits of integration, you get this expression right here. Now, what we're really doing at the end of the day is we're going to be taking this limit of this integral. The integral came out to be that 1/3 b cubed ln b minus 1/9 b cubed plus 1/9, and we're going to be taking the limit of that. And the issue here is going to come from the first term. The 1/9 b cubed, that's 0. The 1/9 stays. The issue is taking the limit as b approaches 0 from the right of 1/3 b cubed ln b. Why is that? Because as you approach 0, b cubed approaches 0, and ln of b approaches negative infinity. So you get 0 times negative infinity, which is one of those indeterminate forms. So it's a form which we can't say the result from it, so you have to get a little creative. And one thing you can do with this function here is you can rewrite it as follows. I'm going to keep the 1/3 b cubed on the top. Sorry. I'm going to keep the ln b on the top. And I'm going to rewrite, and the 1/3 as well. And I'm going to rewrite the b to the third as b to the minus 3. Okay, ln of b over b to the minus 3 to be more specific. That is equivalent to what I have up here. If you just think of b to the negative 3 as a negative exponent goes to the top. But anyways, the reason I'm doing this is because now it's in the form of L'Hopital's rule. The bottom would go to infinity, and the numerator goes to negative infinity. So infinity over infinity. So we can go ahead and use L'Hopital's rule here. And if we did L'Hopital, you would have 1 over 3 times 1 over b all over minus 3b to the minus 4, limit as b approaches 0. And what I suggest you do at this point is to simplify this out. So you flip the b to the minus 4, this whole thing, and dealing with that minus 3 on the bottom, this would be minus 1/9 b to the third as b approaches 0 here. So you would go ahead and take that limit now, and that's just going to give you 0. So the whole thing we had here on the top of 1/3 b cubed ln b, that goes to 0. So your final answer is 1/9, and we would say basically that this integral converges, okay? And that's what your answer would come out to. In particular, when you're working with these integration by parts with an LN, it is often the case that you have to use like L'Hopital's rule from my experience. So just be aware of that. Okay, I hope this helps. Thank you very much for your time.